I hope the voice is audible to everyone. Thanks for coming to this session today. I'm very excited to walk through what we have been working for over years and explain a new frontier of MLOps that I feel would be becoming more and more dominant over the coming years. Right? So before starting, I want to talk a little bit about the title that we have. Right? So hyperscaling real-time personalization, right? Lots of technical words, lots of complex words merged together. But to break it down, what I believe in terms of hyperscaling, there are two core important factors on how do we decide whether the personalization is going better or not, right? One is how much of data are we processing for our systems, right? What's the bare minimum interval between two successive data points? Are we generating new predictions every millisecond? Are we generating new predictions every 10 seconds? Or are we doing it once in 6 hours, once in 12 hours? Right? That determines how granular can we go in terms of understanding the user and responding to his actions. The other aspect of personalization is what kind of patterns can we accommodate into our machine learning systems. Right? So on one side, we have all the generalized models that we are training, which understands what's the majority behavior of the population. Right? On the other side, there are user-specific idiosyncrasies, user-specific repeated patterns that you might not see within the larger population. So those are the ones that get lost out, those long-tail patterns in the centralized training of our systems. So if we are running one model for all the users, we lose out on that. That's where the entire big picture of large language models have been coming into this, because you have trillions of parameters to store trillions of patterns to recognize them and respond accordingly. I'll show you another way to leverage same kind of information storage capacity with a different kind of architecture. And that's on-device computing. Okay. So at a quick glance, for hyperscaling any kind of personalization system, we want to boost our efforts in going as granular as possible, and we want to boost our efforts in understanding the user at the very maximum level that we can do, right? So that even if that means running 100 million models for 100 million users, that's the epitome of personalization I would want to see. So that's what we say hyperscaling for our real-time systems. Okay, I think cloud as a system and a technology, right, it has transformed just the entire application ecosystem at this moment. So be it gaming, be it e-commerce, be it fintech, or SaaS businesses, we see cloud powering all the different kinds of applications and tool sets around that. And there's a very good reason it was such a transformative technology. It brought homogeneity into the heterogeneous world that we had. We don't have to care about all the different devices, all the different network bandwidths and other things. We deploy our system into a contained environment where we know what's happening. Right? So it helped us overcome the diversity that is there in the actual physical world. And it gave us enormous flexibility in terms of what we want to deploy, on what kind of users do we want to deploy, and when we even want to process all of that data. Because of that, it has grown into adoption like anything, right? It has become a $1 trillion ecosystem at this moment. Coming to the decade that is forward, I believe we have started, because of all of these benefits, over-relying on the cloud at this moment. We have understood that there's so many things cloud can do, but there's also limitations on what it cannot do. Right? If I want to run, let's say, 100 million models for my users, I can't do that. I'll go out of my memory, or I'll go bankrupt. Either of those two things, right? So there's an inherent limitation to how much cloud can achieve, and the infrastructure stack from there needs to be augmented to support the scaling efforts that are going to come in the future. Our devices are getting better and better. Right now, my smartphone has the same compute power as the laptop projecting this screen. Right? So we are going to analyze more and more data. We are going to be understanding more granular details about our user. We want to be collecting more data, but at the same time, we have privacy regulations and other things coming into picture. How do we figure out how to define the infrastructure stack for the coming years? And so that's where I believe cloud provided a lot of kick into deploying ML solutions, but now there's a better way out that is coming into in terms of platform and tooling that is available for all the machine learning engineers and data scientists. So before I dive into that, I want to show how machine learning looks like today. Right, so this is more of a standard recommendation, real-time recommendation pipeline that we have picked up. So you'll have user interactions coming from one side. It will all be fed into your Kafka, RabbitMQ, those kinds of queues. Then there would be backend services processing that queue in real time, pushing that data into Spark and Flink clusters. They'll be calculating all the streaming features that you want to understand about your users, right? How much did I click on this particular item? Did I view this? Did I scroll through this particular product? All of those events are being fed into the streaming processing systems, right? In parallel, all the long-term distributions, all the long-tail features that you want to calculate, you will be evaluating those via batch jobs. Those would be directly written into your warehouse, and then you finally club all of that system into a feature store, right? So feature stores basically behave as the backbone for your data. All the online prediction services, all the model training is happening through these data points that are coming along. Right? Now, if I would have started building machine learning pipelines just after my college degree of thinking that I know everything about ML, I would just get scared out of what is this thing. Right? This is scary to understand. This is scary to deploy. It takes enterprises 6 to 7 months for the first time when they're deploying their real-time pipelines. And it has its reasons, right? There are so many components in this. Each component is independently scalable. And based on the spiky traffic, based on the throughput that you have to manage, you have to understand each and every component of this. How do you manage latencies across the overall system? How do you manage the infrastructure cost across the overall system? And when you are deploying new real-time session-aware models, you have to understand which all components of this infrastructure stack would be changed, right? If I am YouTube, I am doing session-aware recommendations for the next video that I want to show to the users, I might be just running a buffer of last 10 videos that I've seen. And that buffer keeps on moving along, right? Now that buffer is an actual physical system that you have to implement in either your feature stores or in your streaming pipeline to keep it continuously running for all the users. And when it becomes 1 million users, 10 million users, 1 billion users, it goes out of scale. These are all the basic challenges that we face when we are deploying these systems on the cloud. And the primary reason, the core crux behind all of this is because it's a centralized system. You have to collect all of that data. You have to process all of that data in real time for millions and billions of users. Right? That's the core problem in this. If I am talking about GDPR compliance, HIPAA compliance, privacy regulations, at the same time I'm talking about personalization. So one is saying me to collect data, another is saying not collect data. What should I do over here? At one side, my business is saying we should increase our revenue, we should grow our user base. On the other side, they're saying bring down your cloud cost. How do I do that? So these are the standard trade-offs that we have just gotten acclimatized to. We have understood that, okay, either we take privacy or we take personalization. Either we take revenues or either we go for cloud cost reduction. We have to choose what's the primary objective enterprise is looking for. So, and doing after all of this balancing that comes across, then I have to plan for 6 months ahead of time so that I know that right now, today I have to build and deploy a model. I have to work with my engineering team, I have to work with my infrastructure team so that I can get the infrastructure ready so that 6 months down the line, I can actually run that model. Right? So many complexities across the stack. How do we simplify it? So that's where I say edge computing or on-device computing comes into picture. Because the system is decentralized to its very core, we don't ever have to handle scale. And because we don't have to handle scale, we don't have to deal with all the problems in terms of that componentization that we saw. Right? So it doesn't matter to me if I have 1 million users or I have 1 billion users. It's running on the devices, I don't care. It's the best possible performance I could get. I'm not taking any data out of the systems. It's privacy aware by design. All the PII data stays on the very hands of the users. If they want to delete it, they can just clear the cache. So I'm privacy aware, but I'm utilizing all of that data to train my models, to run my models. So I am giving them the personalization that my users need without worrying about the PII data and the entire GDPR compliance, that 10-pager compliance that comes along with it. Right? And edge computing, again, it's running on the actual handheld devices of the users. The entire pipeline is running over there. You don't have to pay enormous amounts of money to AWS or Azure as your users are growing. Right? You are leveraging the compute capabilities of the devices of your own users. They are contributing to the better system for you. So there are no infrastructure costs associated. There's more revenue for you. There's personalization. At the same time, how much real time you want to go, there's no restriction. You want to process data every 80 microseconds, go ahead. No one is stopping you from doing that. So, and you do all of that while everything is running on the device, so you don't have to rely on the internet connection. If the user is moving on a car or if he's in some jungle across the continent, doesn't matter because your personalization engine will still run. Your latencies would be 5 to 10 milliseconds from our experiences in the last 3 years of deployment. That's about 50 times faster than what you will get on a cloud, right? The cloud will give you 8 milliseconds of latency, but it gives you 300 milliseconds of network connectivity as well. You have to ping the servers, get the responses back, and show it to the users. So that's how I believe a more better infrastructure could be built out, adhering to the norms and regulations that are coming for the future, while at the same time not compromising with our own revenue growth and our own personalization charter. So in this talk, the rest of the talk would be focusing more on how we have worked with our customers in the past and gains across each one of these aspects that we have seen. So be it in terms of machine learning performance, be it in terms of diversity of devices that you have to handle, or the infrastructure costs. Okay. So I would say if we went 3 years back, right, that 3 to 4 years back, that's when I started working in this space for the first time, and I realized that running machine learning models on the devices is also super complicated. Right? So the theory around this used to look very good, but there was no tooling to actually support this. Right? TensorFlow was giving some basic execution systems. PyTorch came up with TorchScript, did to some extent what we wanted. But in a recommendation engine, we also have to do data processing. We also have to store data. We have to update all of these on the fly. We don't want that every time our machine learning model needs to change, we have to ship a new application rollout. And so all of those were problems back in the days when we first started building all of this infrastructure. At this point, I would say there are tools, there are platforms available to give the same flexibility that you expect from a cloud. You can on the fly update everything that is running on the devices. As a machine learning engineer, you can control what's happening on those devices from your cloud without shipping a new app update. And the very familiar terms that we have accustomed on the cloud, you get one-to-one correspondence for those on the devices. You have a data warehouse on the cloud, you have a data warehouse on the device. You have a data processing engine over there, you have one on the device. You have feature stores, you have training systems, you have inference systems. Everything that you need to orchestrate your machine learning pipeline, now it's there on the device, helping you deploy within 7 days of starting the entire process. And in this case, there's no scale problem. Once you build out the model, you can go live. Like Our fastest integration with our previous customers were 5 days. And that too when we were deploying it at the scale of 150 million users. So I think in terms of ecosystem for the mobile apps, in terms of what we need as data scientists and machine learning engineers, there's a lot available in place already for us to get started. There are things, of course, where if you are interested, would love to chat more, where everyone can contribute and make those systems better. But there won't be a limitation for you to try this technology and deploy it. So, for instance, I'll focus on one specific aspect. So this was a conversation that was happening on the conference app. So we asked, how do you improve the performance of your machine learning models? So the folks over there gave responses that I'll pump in more data into my ML models. I'll go real time. Or let's say, I'll build smaller cohorts. Right? So now smaller cohorts is basically what attunes to the direction I was going forward with. So as a top, this is how your global data distribution is going to look like. Right? With all the different sets of users, the averaged population distribution will come something like that. Any data, any model trained on this system would be working for all of those users at the same time. While the actual distribution of the users is something that you see below. Right? It's slightly deviated from the global distribution. And this is where those user-specific patterns that I was talking about in the beginning come into the picture. These differences are what is lost when you train on a global system. So you need to understand the global distribution, but at the same time, you need to understand those slight differences from the global distribution for your models to perform absolutely in sync with what the user is intending to do. And when we do this boosts accuracies by 5 to 10% on an average. There are multiple papers in the space with big companies showing the same results again and again. So they have deployed these systems to 1.2 billion users, and they have still got 1% uplift at that scale. Right? This has been aligning well to our deployments as well. Every time we deployed these systems, that's the kinds of accuracy uplifts we have seen. It is powered by both going more real time and understanding more about the users. And yes, I was talking about this. Privacy is achievable in this case. I think it would be pretty clear that we are not sending out data anymore from the devices for doing all the analytics, all the data processing, and generating predictions. So we are compliant with the 3 basic principles any data regulation is being formed at this point. Before NimbleEdge, I had lots and lots of conversations with legal teams across the world when they were planning out what kind of regulation should actually be enforced for the enterprises. And these were the founding principles that I've seen come up into conversations again and again. Right? So data minimization, for instance, is you want to collect data for a particular use case, just do that for that use case. It should not be utilized for anything else. If you want to utilize that data for some analytics with some third-party vendor, you have to enforce that the use case is always controlled and it's being used only for that. It's so Grindr got that heavily fined by GDPR because of this thing. Purpose limitation is again this. You want to restrict misuse of the data. You don't want to collect data that you don't need. And fairness is you want to reduce bias in terms of the majority population as much as it's possible. Now, with techniques like federated learning, when you are not sending raw data out of the device, but you are sending trained models from those devices back into the servers, those models can really be only used for the purpose they were trained. Right? If I have trained a recommendation model to show me newsfeed, it can only do newsfeed. It can't do anything else if they don't have the raw data backing that model. So purpose limitation is inherent in cases where you decouple PII data with the models. Same with the fairness and transparency, and same with data minimization. So yeah, now let's talk about the cost savings that I was sharing. Right? I want to scale to more and more users without going bankrupt, without paying half of the revenue that I earn to AWS or Azure. Right? So this is basically the cloud breakup of the pipeline that I was showing in the beginning, and what happens to the same pipeline when it's running on the edge. So you might still want to store all of that data that you were collecting for, let's say, later on analytics. It's dependent on you. It's not required anymore for the real-time pipeline that you're running. So we didn't change the storage cost in these cases, right? But all the things like Spark streaming, feature store, Spark batch ETL, backend services, there's a heavy cost reduction that comes across for all of those. You don't need a backend service anymore because your backend service is now actually running on the front end, right? You don't need an inference service again. Spark jobs you might still want to run. So you might still want to understand, okay, what's the most popular product in my user amongst my users at this moment. So you have to aggregate that information on the cloud. So those are basically 20 to 30% of all the ML features that are being fed into the systems. So we keep those 20 to 30% costs, we still do it on the cloud. Rest 70% of the features that are user specific, we are running it on the device. So that brings about on an average 50% cost reduction, sometimes it goes even to 70 to 80%. So you are faster on the edge, you are privacy aware on the edge, and you are way more efficient in terms of spending your machine learning budget on the edge. Why don't we do it? Right? So with all of this, I want to show one video. This is our team built out as a demonstration of the capabilities of on-device computing. Assume it's an e-commerce app, kind of like Instacart or DoorDash. They are showing all the different kinds of grocery items that you can buy. And the models needs to understand what products to be recommended based on each and every interaction, be it scroll, be it view, be it click through it or add to cart. And even search. So if I am searching, this is doing a neural search behind the scenes. All of this is powered by the device. I can switch off the internet and it will still run.
Hey, what's happening, guys? It's 8 a.m. right now and I really need to eat something. So I'll be making use of NimbleEdge that will personalize recommendations in real time for me. I generally crave sweets a lot, so let's see what options do we have here today. Maple syrup looks really, really good. Wow, NimbleEdge just recommended me with all of the items needed to make a pancake in under 2 milliseconds. But I have a feeling pancakes might be a little too heavy for me. Maybe a taco would do the job? Still not so sure. Aha, I'm definitely in the mood for salsa. Looks like NimbleEdge has recommended me with all of the raw materials needed to make a burrito. Decision made.
Right? So yeah, that's basically all the kinds of recommendations, all the kinds of user interaction that you want to do. It's possible to do it on the device. Doesn't matter you have a 10,000 product catalog or 100,000 product catalog. There are tools that help you enable that, and there are tools that can expedite your deployment cycles, at the same time simplifying the entire complexity that we see on the cloud. Right? So I believe that with edge computing, it should really incorporate and augment the existing pipelines that we are seeing on the cloud. It's really a new frontier that is opening up with more capabilities on these devices. So I would be more than happy if you are interested to ask any questions on this front. We also have a booth over there at 16. You can reach us out over there. And this QR code is there for if you are looking out for trying out edge computing. It gives 5,000 devices worth of free quota for you. So you can use it, apply it, and you'll get free Nimble credits. It will give you an way to try edge and see for yourself All I am talking about is that really possible or not for you. That's it, guys.